Hello friends, welcome to Shiksharthi. In this video, we shall be discussing the basics and the concepts of the mensuration aspect of circles. So let's start. Now when we are talking about circles and we are talking about the mensuration part, so the mensuration part here refers to, we'll be talking about the area of a circle, the circumference of a circle, the area of a sector, the circumference of the sector, and so on. So now when we draw a circle here, and if I take any, let's say this is the center point, and the center point I'm taking it as O. Now from this point O, if I draw a straight line, and this point which I'm taking on the circumference of the circle, if this point is A. Now in this case I can say that OA is nothing but the radius of the circle. Now this is one side of it. Now if I extend this line straight, I have just extended this line and made it as a straight line, and let's say I take this point as B. So in that case OA is equal to OB, which is equal to the radius. And then I can say that AB becomes the diameter of the circle, and the diameter in this case becomes twice of the radius. So let's say if this is R, the diameter would be twice of R. Okay, now taking this discussion forward, so this was the first thing that we talked about circles, wherein we need to know what is the radius. So radius is a point, let's say is a distance, is a line segment, is the length of a line segment which joins the center point to any other point lying on the circumference of the circle. So for example, if I take any other point which passes, if I take any other line which passes through the center, and let's say I take this as C and D. So in that case I can say that OC is equal to OD is equal to radius. And then I know the relationship that we have already established, and then henceforth I can say that AB is equal to CD, which is equal to the diameter, which we also call it as a special chord. So from here we get the definition of the chord also. Now what is a chord? Chord is a line segment joining 2 points, any 2 points. It's a straight line segment. It's a line segment joining any 2 points on the circumference of the circle. It may or may not pass through the center. If it passes through the center, then we call it as a special chord, and the special chord becomes the diameter. Else it is a non-diameter chord, right? Okay, talking about point number 2. Now let us say that now can I say BD is a chord? Now even before, how is a chord formed? So chord is formed by choosing any 2 points on the circle, any 2 points, and here the any 2 points that I have chosen here are B and D, and the third point which I am choosing here, let's say, is E. So can I say, now this is an arc. What is an arc? You choose any 2 points lying on a circle, and when I measure this, when I move from this to this, so this is a circular movement. So this circular, the line, the circular line. Now you may say that what do you mean by a circular line? So a circular line is a kind of a straight line only in the form of a circle, in the form of an arc, that is circular. So now what is an arc? Arc is a circular straight line. So can I say arc BED becomes what? Becomes my minor arc. And why do I say this becomes a minor arc? Because the angle which is subtended by this arc, or let us say the angle which is subtended by the arc resulting into a chord, and this angle which is subtended at the center of is known as the angle subtended by the arc. So angle subtended by the arc is nothing but the chord that is formed because of the arc, which subtends the angle at the center. So can I say all these are equal, as discussed few minutes back? Now let us say this angle is x. In that case, the remaining angle that I talk about, so if I talk about this angle, this will be 360 degrees minus x degrees, if this is x degrees. So can I say this is minor arc is because of the fact that the angle which this arc subtends at the center. Now this is no doubt greater than 0 degrees, but it is lesser than 180 degrees. And every minor arc would result into a major arc also. For example, here I can say BCD or BAD. So let's say arc BCD is known to be a major arc. And why is this known to be a major arc? Because the angle which it is subtending, and the angle here is 360 degrees minus x degrees. This will definitely be greater than 180 degrees, but it will be lesser than or equal to. Can it be equal to? No, it will be lesser than 360 degrees. This is the definition of minor arc and a major arc. So taking this discussion forward, point number 3, can I say that a circle is formed out of a major plus a minor arc? So let's say major arc BCD plus the minor arc. No, what is the minor arc here? BED. This is how a circle is formed. Okay. So we understood about what is the radius, what is the diameter, what is the definition of an arc, and so on. Now, the moment I start off with an arc, I talk about chord. The moment there is, now if I talk about the area enclosed between the chord and the arc, the same arc in which the chord lies, we call this as the segment. This becomes the segment area. This is segment area. So segment is always formed with the help of the arc, and the arc, from the same arc you are able to draw a chord. That is how you get the segment. So segment area in this case will be BED. So this becomes your minor segment. And then you have the major segment also. So what is the major segment? The remaining part. So the remaining part, the entire portion. So if I had to shade this entire thing, the remaining part results into segment area. The minor segment area and the major segment area. So as I was saying, segment area. So this is BED is your minor segment, and let's say BAD, or let's say take it as BCD. This becomes a major. So major segment and the minor segment gives rise to the area, right? An arc, if I take all such arcs, if I combine all such arcs, I get the circumference. So this was talking about when you're talking about the circle, and then you're talking about the area, and then you're talking about the circumference. So how do I get a circumference? I get the circumference with the help of the circumference of a circle is nothing but the minor arc. In this case, the minor arc is BED plus the major arc, and the major arc here is BCD. And how do you get the area of a circle? Area of a circle, here we talked about the minor and the major, and the definition of the minor and major comes from the angle which that particular arc or the chord subtends at the center. What is the definition of, if somebody says that this is the angle made by the arc, minor arc angle. Minor arc angle is nothing but the angle subtended by the minor arc or the chord resulting out of the minor arc to the center. that is the minor angle, or the angle subtended by the minor arc. Okay, so now finally if I talk about the angle, so can I say the minor arc angle plus the major arc angle should be equal to a 360 degrees? Of course, the minor arc angle plus the major arc angle should be equal to 360 degrees. Right, now few points that you can always, which can come out of this is, so can I say a minor chord? And now you will understand what is the definition of a minor chord. The chord which is given rise to because of the minor arc. So here it is. And then I talk about the major chord. But then this becomes, whether you talk about minor chord or you talk about major chord, the chord remains the same. So which is why you will see that we never talk about major or minor chord. We simply talk about the chord, because there is an accord between the two. So what is the accord? If I am talking about this chord, the chord divides the circle into two parts. Now those two parts may be equal halves, may be unequal halves, but the half itself is half of it. So if a chord divides this circle into two equal halves, we know that that chord becomes a special chord, which is the diameter, else it is just known as a chord. Okay. Now the final discussion here. So let's say point number 8. So now if I have to find out the length of this arc, what do I do? There are two ways of doing it. One is I come down to, I take all such very minute things and I, let us say, I add this, let's say this is F. Then I take another point on the circle, let's say it is G. And then I keep on adding all these lengths, I calculate all these lengths, and then it results into something. So now I keep on dividing the circle into, let's say, n parts for all these lengths. For all these lengths, I keep on dividing it into n parts. Right, which is just like saying, if I divide a circle into 18 parts, what would be the angle subtended by every arc? 18 such arcs that would have been given rise to. It will be 18 into 20, which is 360 degrees. Correct? So from there, or another way of finding out here is, we know that circumference of a circle is nothing but 2 pi into r. Correct? Now what is 2 pi into r? Now 2 pi is, now this is nothing but the r that you are getting, and 2 pi is the entire, now let's say this is r, right? And when this r keeps on moving and it moves through 360 degrees, which is nothing but 2 pi, we get the entire circle, which is just like saying the circular movement that you are doing, which is what I was explaining to you. Okay. So now we know that the circumference of the entire circle is 2 pi r of the entire circle. Now entire circle is just like saying a 360 degrees divided by a 360 degrees. Had it been a sector, now the sector here is, okay, where should I draw a diagram? So let us say that I am drawing a diagram here. And here I am talking about the same thing, the same diagram I am taking here. Let's say this is point B and this is point D, and the angle which it makes here is x degrees. So this is the arc and these are the lateral sides of the arc, and the lateral sides of the arc are nothing but the radius itself, and this point is nothing but the center. Now if I want to calculate the length of this arc BD, right, so length of the arc is nothing but length of the arc BD, and here we are talking about the circular length. As we talked about, what is an arc? Arc is a circular straight line segment, to be precise. So what is the length of the arc BD here? The length of the arc BD is nothing but you can extend the formula from here itself. So which is just like saying this is 2 pi r, and when you are taking an arc would not subtend an angle of 360 degrees. It is subtending what? X degrees divided by 360 degrees, because had it been the entire circle, then this becomes 360 degrees upon 360 degrees. This is the length of the arc BD. Next point which is important here is talking about the area of the arc. Now, there is no area of the arc. Now, how is an area formed? Area requires an enclosure. It requires an enclosed figure. So here the enclosed figure is OBD. So area of, now this becomes the sector. What is the sector? The curved surface plus the linear surface encloses an area. So the same curved surface when is extended towards the center. Now this entire figure is what? OBD. So which is now, so area of the sector OBD is how a sector is formed. Is nothing but, do we know the area of the circle? Area of the circle is nothing but pi r square. Now the same thing that we could have talked about here, area of the circle is pi r square into 360 upon 360 is what we can say. But here the angle as subtended by the entire arc of the circle, the entire arc is, we are talking about the major and the minor arc both. That is how we calculate the area of the entire circle. So area of the sector OBD, so which in this case becomes what? The minor sector, let's say, just to understand it specifically, will be how much? This will be nothing but x degrees divided by 360 degrees. It becomes so easy to remember the formula. And taking this discussion forward, can I say that the area of the sector, the major sector OBD, which is nothing but the remaining circle, the remaining part of the circle, which is this, will be nothing but pi r square into 360 degrees minus x degrees is what we discussed, divided by 360 degrees. And we know that a circle is formed because of the major part of it and the minor part of it. So when we talk about the circumference of a circle, it will be the major circumference and the minor circumference. When you are talking about the area of the circle, then it will be the major sector and the minor sector. Okay, when you combine them, then you get the area of the entire circle, which is just like saying you add both of these and then you should get the area of the circle. So area of the circle in this case becomes how much? It becomes, you can take pi r square as common, and then x by 360 degrees minus x by 360 degrees into 360 upon 360 degrees, which is equal to pi r square, which becomes so interesting, so interesting. But then there is the last thing that I want to discuss here is, if they are talking about the circumference of a semicircle or the circumference of any part of a circle, please remember that the circumference is formed because of adding all the surfaces, whether it is a curved surface or a linear surface, which is a non-curved surface. For example, if I have to find out the circumference of the figure OBD, I'll say what? The circumference will be OB plus OD plus the arc BD. This will give me the net circumference of this part. Which part? I'm talking about the sector OBD. So a sector can have a sector area also, and they may ask you to find out the circumference of the sector. And when you are finding out the circumference of any figure, you know that the circumference of any figure is nothing but you add all the sides. In case of a circle, if you are taking a pi of a circle, you are taking a portion of a circle, in that case the circumference of that portion would be the linear surface plus the non-linear surface, or the curved surface plus the non-curved surface. So coming back, if they give you a semicircle and they ask you to find out the circumference of a semicircle, so I'm taking the example here. So for example, they give you a semicircle. Let's say this point is O circle ka center and this point is B. and they ask you to find out. Now this circle is divided into two parts and they are asking you to find out the circumference of the semicircle. So what will you do? You do the same thing as you had done there. You will say what? You will say OA plus OB plus the curved surface, which is arc length, which is AB. Now in this case, you know that this is nothing but OA and OB are same as we had taken here, OA and OB. So in this case, this becomes twice of R plus the curved surface length, and the curved surface length is nothing but half of this. Or, so when I take half of this, this comes out to be how much? Pi R. Had they given you to find out the circumference of this pi, the pi here is the sector. In this case, you would have said that this is 2R plus how much? Plus this length. And what is this length? You need to add this length to it. In case of a semicircle, this x degree becomes how much? 180 degrees. I hope you would have understood this. If you feel that this video is really knowledgeable and it takes your learning to a next level, do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you get regular updates from us. If you want us to do videos on some topics which are difficult to comprehend, don't hesitate and put it in the comment section so that we can do it for you. Thank you so much. Until next we meet, goodbye.